Hi ladies, in this video we're going to go through the theory for 4D and some of the harder questions. So we are looking at bearings. So bearings basically just relates to what direction we're going in. So you've probably heard about north, east, south and west, and that a full revolution of a circle is 360, and you have all these other angles on the side. So let me just get my pen ready. So we've got north up here at 0 and then back at 360, and then we always go in a clockwise direction around. So you can see northeast is at 45 degrees, 90 degrees, 135, 180, 225, 270, 315, and so on. If you want to remember northeast, southwest, never eat soggy Wheaties. I don't know, maybe you were told something else in primary school, but hopefully whatever you use sticks with you. Now, when we're looking at bearings, you can have something called compass bearings and true bearings. So we're only going to be looking at true bearings for the time being. Okay, compass bearings you also won't see if you go on to do further maths. We tend to just use true bearings, but compass bearings, basically you're going in the north or the south, going from the north or the south in the east or west direction. But true bearings are a little bit easier because you're always just got a bearing from 0 to 360. Now, in trigonometry, we always use bearings to create a triangle, and at the moment we're just dealing with right angle triangles. So usually you're going in a certain direction and you're asked how far east you've gone or how far north you've gone. But obviously you can also apply to non-right angle triangles, so don't just assume that bearings relates to right angle triangles. All right. Now, question 1 we're going to do as a class, and also question 3. So I'm just going to scroll on past them and move down to the harder ones. So a ship travels due south for 3 kilometres and then on a true bearing of 130 degrees for 35 kilometres. Now, when I draw a diagram, no diagram has been given to you. Give yourself enough space. Don't just go over here to the left side, because you could be going in the westerly direction and then you'd be off your page. So I always just, start with enough space going around. A ship travels due south for 3 kilometres, so it's going down. So if it helps, you can always just draw on the side north, east, south, west. So obviously south is going down. You can have north facing a different direction, but we tend to just have north pointing up, just makes things a whole lot easier. Okay, so that's 3 kilometres. And then on a bearing of 130 degrees for 5 kilometres. So we've got to kind of work out where 130 is. So if we're going from north to east, that's 90 degrees. And then if we went to east to south, that's 180. So 130 degrees is somewhere between east and south. So going down something like that, and it's going to be 5. So I'll just make that line a little bit longer. Okay, and so this angle is 130 degrees. Find how far east the ship is from its starting point, correct to 2 decimal places. So you've just got to create a triangle. So I'm going to go across and then down, and you can see there's my right angle triangle. So I'm going to redraw that over here. With bearings, you're going to always have so many lines and circles representing your angles that it's a good idea to take out the triangle. So this is 5. And this angle here is just 130 minus 90, which is 40. And we want to know how far east. So I'm just going to call that E. E for east, you can call it X, or whatever you like. Okay, so identify your sides. So hypotenuse, opposite, adjacent. So I'm just going to identify that over here. So hypotenuse is 5. Your opposite, we don't have a length for, so I'm just going to cross that out. Adjacent is labelled as east, and theta is 40. So because I'm dealing with O and A, I'm going to be using the cos ratio. So cos theta equals adjacent over hypotenuse. And then I just substitute in what I've got. And to get east, sorry, we're just going to have to multiply both sides by 5. So they cancel out. So east is equal to 5 cos 40. And then you just need to do that on your calculator. So let's get the CAS up. 5 cos 40. I'm just making sure it's in degree mode. Okay, so we get 3.83. And that's in kilometers. Now, how far south from the ship how far south the ship is from its starting point, correct to 2 decimal places. So we're basically going from its starting point. So it's already gone 3. So we've got to add on this little bit here. If you want to call it X, you can. And that's the same as this side over here. So if you're identifying your triangle, you can keep the same triangle as this and identifying HOA, theta. All right, H is 5, opposite is X, adjacent. Now, I worked it out here, and I could use it again, but always use values given to you. So I'm not going to use adjacent. I'm just going to stick with opposite and hypotenuse, and theta is 40. So we're going to have sine theta equals opposite over hypotenuse, sine X equals opposite, which is X over 5. Just had a bit of a blank then. Times 5 times 5. Whoops. Okay, and they cancel out. So X is equal to 5. I knew I did something wrong. I don't know whether you noticed me pausing. I shouldn't have had that X there. It should be 40. There we go. Sine 40. 5 sine 40. Oh. Now, it's always a good idea to put the number at the front of sine. It doesn't really matter. But it just depends how you put it into your calculator. 5, and we usually write it at the front, so 40. 3.21. So 3.21 kilometers. So south is 3 plus 3.12. So 3 plus 3.12, because it's already travelled 3 kilometers, 6.12 km. Okay, let's go on to the next one. 2 points A and B positioned 15 centimeters apart are such that B is on a true bearing of 100 degrees from A. So it's drawn that for us. And A and B are 15 centimeters. So I'll put it on the diagram. Find how far east point B is from A. So we're going across, finding that distance, and then how far south. So we're going down. So let's draw that triangle again. Now it's a right angle. This side is 15. And theta, remember, from north to east is 90. So this little angle in here is just 100 minus 90, which is 10. Okay, so let's do question A. So identifying everything. So your hypotenuse is 15. Now we're working at east, so you can call that E again for east if you like. Adjacent side we're not dealing with. I'll do that in the second question. So I'll cancel that out, and theta is 10. Now I'm not going to go ahead and do all of this because it's pretty similar to the previous question. We're just using the sine ratio now. So sine 10 equals opposite over 15. Now for question B, identifying everything. Now I've got my adjacent side, so that's how far south. So I'm just going to write S. So 15. Opposite side, now you can, oh no, I've called that S, sorry. No, oh no. I just realized I made a boo-boo. Okay. That's wrong. That should be adjacent. I'm not going to pause. Usually I would cut that out, but there we go. Opposite is not what we want, and east is adjacent. Okay, so I should have used cos theta equals A over H. There we go. Cos 10. Adjacent is east over 15. There we go. All right, let's move on to B. So your opposite side this time is S. Adjacent, now I'm not going to use this value because it's better to use what you've been given in the question. You'll be more accurate, and 10. So now I use sine theta equals opposite over hypotenuse. Sine 10 equals south over 15. Okay, and then you can just solve for east and south. All right, next question. A bushwalker hikes due north from a resting place for 1.5 kilometers to a waterhole, and then on a true bearing of 315 degrees for 2 kilometers to a base camp. Okay, so let's just set up north first. That just kind of helps. East, south, west. It's gone, the bushwalker has gone north, so it's gone up 1.5 and to a waterhole. So it's started at its resting place. If you want a resting place, waterhole. And then on a true bearing of 315. So west is at 270, north is at 360. So 315 is just on the side here. And that was 2 kilometers to base camp. So camp. What are we to? Find how far west the base camp is from the waterhole. So we're looking for this distance here. Find how far north the base camp is from the waterhole. So that's that distance there. Find how far north the base camp is from the original resting place. So then you're adding on 1.5. So let's take the triangle out. Okay, so this is 2. Now, this bearing in here, this angle, remember we go clockwise, so I'm going right around all the way to about here. So this angle in here is just 315 minus 270, which is 45, and we love 45 because it now makes it a nice isosceles triangle. So this distance here, which if I call that x, is also the same as this distance here. So you're basically going to get the same answer for A and B. And then for question C, you're just adding on the 1.5. So just like I did before, let's just do west. Label your triangle. So I'm going to call this my hypotenuse, my adjacent, my opposite. So HOA theta, hypotenuse is 2, opposite. Now, I've got 2 x's, but because I'm doing west, I need to work out, I need to use adjacent, but you get the same answer. Okay, and then theta is 45. So I'm going to be using the cos ratio, and cos 45 equals x over 2. So x is equal to 2 cos 45. All right, and I'll let you do the rest of the question. All right, question 9. On a camp, point C is 4.3 kilometers due east of point B, whereas point B is 2.7 kilometers on a true bearing of 143 degrees from point A. Give your answer to 2 decimal places for the following. So questions like this are majorly confusing. So first thing, set up your north, east, south, west. That just helps you get your bearings. Okay, so we're going 4.3, C is 4.3 kilometers due east from point B. Give yourself enough space for your picture. It's due east. So here's C, it's due east of B. 4.3 kilometers. Point B is 2.7 kilometers on a true bearing of 143 degrees from point A. So 143 degrees is between E and S. So it's somewhere down like this direction. So B is from point A. So you've got to kind of think, here's A and here's B. So it's kind of a bit backwards, but there's your A. And let's just put in some more information. So this angle here is 143. And did I give a distance here? 2.7. All right, so let's choose another color. Blue. Okay, so how far east point B is from point A? So this distance here, I'll just turn it into a right angle triangle. Redraw the triangle over here. So this hypotenuse is 2.7. The angle up here, 143 minus 90, because that's a right angle in there, so 53. And, okay, so we're doing how far east? I'm going to just use E again. Label your triangle. So H, O, A. So hypotenuse is 2.7. Opposite, we don't need to cross it out. Adjacent side I've labelled as E for east, and theta is 53. So I'm going to be using the cos ratio. So east is 2.7 cos 53. So you can pop that into your calculator. All right, next one, how far east point C is from A? Oh, well, we just add on 4.3. So 4.3 plus 2.7 cos 53. How far south point C is from A? So we're just looking for this opposite side. So this side here, which I'm sure you'll be able to do. And I think that might be it. Is there another question? No. So I just wanted to keep it short, girls, but if you come across anything you don't understand, please let me know. Bye.